Hello, everyone. My name is Shan. I'm the co-contributor of Kepler.gl. So today I'm going to talk a little bit about Kepler.gl and what's coming to Kepler.gl 3.0. Does show of hands if people here know of Kepler? Okay, so my first couple of slides is going to be very fast. Probably you guys know me. I've been giving talks about Kepler for the past couple of years. My background's in architecture. I, started working at Uber with Xiaoji and Yib, Chris, Adam. It's like a big little Uber crew here. During that time, I open sourced Kepler. Later, Im and I co-founded Unfolded, building studio based off Kepler, and now we're acquired by Foursquare. So I'm continuous building Kepler, which is now called Foursquare Studio. Since my background is in architecture, so geospatial visualization has always been my passion. I like to use the example of demoing how impactful geospatial visualization is. On paper, there are 125 million buildings in the US. I study buildings, so it should mean something to me. But just looking at the numbers and zeros, the numbers is just code and abstract. But when I started doing visualization, the first thing I did is let's try a heat map with 125 million buildings. And this is what I see. Geospatial visualization makes putting data on the map, and even just a little bit of single points on the map, make it extremely relevant, become relevant to our day-to-day life. So, we use geospatial visualization overlays location data on the map, and it makes the data relevant to us and make the patterns immediately jump out. So when I talk about geospatial visualization, this is one word like GIS I cannot avoid talking about. So my take on how GIS become geospatial visualization really lies in the landscape of geospatial industry, the changing of that. Um, oh gosh, it's like 10 years ago when I studied GIS, I was sitting in a computer lab loading ArcGIS and plotting maps of rivers and farmlands, and you got like shape files of census tracts like that been changed every 10 years, and that's all about GIS. Like GIS in the past decades was mostly about things that doesn't change very frequently. But through the recent years of smartphones, GPS devices, remote sensing, like technology allows us to rapidly acquire information about the Earth. We're getting data that has already changed in nature. So we're getting data mostly about how humans move and reside in the physical space, and that to me is a changing threshold where GIS has become geospatial data analysis. Geospatial data analysis is mostly about humans, places, and movement. Humans, we no longer looking at census tract data sets. We're now started looking at heat maps of our of population density. We're able to collect data and synthesizing them into this kind of hexagons to help us understand how humans reside in the physical space. Places is another type of geospatial data we're usually talking about. When I talk about places, I'm not talking about 50W 23rd Street. I'm talking about the Foursquare office in this building. So places is POIs, it's the actual contextual places that we actually go to, and that it's a changing from time to time, since closed, since open, and it's most relevant to us than the address itself. Movement is obvious, like we all come from Uber, and we work with movement data for our careers, where this type of data presents a new landscape for geospatial visualization. Now we have to no longer talking about latitude, longitude, we have to talking about long altitude, speed, and timestamps. All of these new information add to the data has made geospatial analysis and visualization extremely challenging. All of that is just a background of how we decided to build something like Kepler at Uber. At that time, we have billions of data points come to our platform every day. the whole Uber visualization team is tasked to making sense of it. So we built Kepler on top of DeckGL. It's browser-based, it's WebGL based, and GPU accelerated. It has those preset layers and help us quickly create visualization. And it try to capsulize this collection to data processing to visualizing all in one tool. We constantly started to realize there's new type of visualization we can use understand geospatial data, so we package them all into Kepler as this type of layer sets. All of these layers are, you probably commonly use in geospatial visualization. They are relevant when you try to understand GPS data or origin destination to post census tract or building footprints and trajectories. This is my favorite example when I'm talking about use cases of Kepler. And this is one failed Uber pickup at SFO. You can see this, the yellow dotted line is where the driver's coming in, and then the red dot is where the riders. So you can see the driver first missed the rider, and the rider was waiting around, and the driver made a circle around SFO, and then they pick up all together. So when we build up Kepler in Uber, this is the first thing we try to apply to our daily business, just trying to understand exactly what happens for a single failed pickup. And later on, we started to looking into visualizations that's directly from trajectory, not just one single trip. We build up this layer into Kepler called trip layer that can actually interpolate timestamps and connect individual GPS traces into this collection of trajectory. This become the standard for visualizing fleet visualizations later on, packaged into our tool. And the last special features that we package into Kepler is the direct support of H3. H3 is kind of came out of Uber, but not originally designed by Uber. It's a discrete global grid system. It's able to indexing the Earth into this hexagon-shaped cells, and then be able to, at the different zoom level, have different resolution of these hexagon cells, smoothly transition into from children to its parents, from parents to its children. It's very interesting when we started using H3 to indexing, raw GPS data and started calculating features or metrics within each individual cells. Enable to, in order to run actually spatial analysis for such as correlation, anomaly detection, or clustering, we need to be able to bring raw GPS points into H3 system. So this is another feature we just package into Kepler.gl, and we actually use it within Uber at that time to try to understand different metrics, features of a collective trips within each city, and then understand, where, we have most of the ETA errors, where the average trip distance is longer, and where we have most of the tourist trips. So that's just a quick overview of Kepler. And what is behind Kepler? It is a React-based application. It's built on top of DeckGL and using React Map.gl as a wrapper. And the base map is provided by Mapbox.gl. Given that, so let's talk about what's gonna come in Kepler.gl 3.0. So the goal of Kepler.gl 3.0 is really modernize our tech stack. It was written 8 years ago. At that time, TypeScript wasn't a thing. So we spent 6 months time continuously converting thousands of our JS files into TypeScript. And now we're at 100% TypeScript coverage. Also, now we have everything type exported. So if you are using Kepler.gl, in your own project, you can actually get types on these different functions and components they're using. We're also made a big movement to move into monorepo. So now Kepler is not just one import Kepler. You can actually import in submodules of Kepler The React component is its own submodule, the Redux reducer is its own submodule, the layers is its own submodule. This makes Kepler a lot smaller for your project, so you can only importing the the part that you are most using. I know when Chris uses Kepler, he mainly just uses the reducers. He doesn't really use the React components. So changing into a monorepo have submodules make Kepler a lot easier and smaller for you to integrate. We also did a lot of upgrade on our dependencies, including React 18 upgrade, JGL 8.9, and React MapGL 7.0 upgrade. And another goal of Kepler 3.0 is to continuously invest into stability, hardening our features, and the extensibility. We added more than 40 new features and 20 API enhancements and 60 bug fixes. More bug fixes, better. So some of the feature highlighting is Kepler 3.0 integrated with Hubble.gl for video export. So now if you're using features like trip layer or animation, time animation, you can directly export a GIF or a small video based on that. We also replaced React Map GL with Nebula. So this is a library that can draw shapes on maps. So Kepler already have drawing, but to replace it with Nebula, Nebula is GL based drawing library. The interactions are a lot more smoother. We can build it directly into the layer rendering stack. And we can also, extend that to allow you to filter layers based on the new drawing features. We also include the unlock viewport in split maps. So Kepler allows you to show two maps side by side and showing different layers. With a new feature added in, you can now show side by side maps and different viewport in each map. So this is especially helpful if you want to compare different markets like LA versus San Francisco. You can break into split map and have each of the map focusing on different regions. And in the split map, we also have the locked zoom. So this is quite important because we don't really want people to freely zoom in and out on each side. That mess out with the scale. So you can have the zoom being constant between two sides, but having the center of the viewport being different. We also added support for map overlay blending. So this is a difference in layer blending. If you know of Kepler.gl, layers are rendered by DeckGL, base map is rendered by Mapbox.gl. So this difference in rendering technique history has been presenting a challenge. For example, on the left side, you can see our hexagon layers completely blocking the base map. You don't really see what's behind, what's under it. But with the map overlay blending, we can actually just using this basic CSS blending to blend the DeckGL layers with the base Mapbox base map. So when we added this blending feature, you can see the base map pops out from the right side. You can still see the DeckGL layer being rendered, but you can see the background map popping up as well. And this is another feature somehow being requested a lot is they just don't want base map. They just don't want base map. This is probably my most favorite statistic features into Kepler is that once you actually have a visualization, comprehensive enough for you to already understand what everything is, base map actually not become irrelevant. So this is one of maps showing the different shipping corridors, the different ship sailing across Atlantic and Pacific Ocean. Without the base map, you can still be able to distinguish where is the continent and where the ocean is. So that's just some of the feature highlights. The very last one we have is also we have Kepler integrated with Foursquare Studio. So when Kepler is a client-side only application, there's no backend to it. So traditionally, you can save your Kepler maps to Dropbox or to Cardo. We added Foursquare Studio support as well. So now you can also save your map into Studio and try it out. With that given intro, that given said, so I think one of the thing we need to talk about is The Kepler team built up Foursquare Studio on top of Kepler. And Studio is like a part of comprehensive geospatial analytic platform. The reason we built Studio on top of Kepler is that we added feature that would require additional backend resources. If you know of Kepler, it's client-side only. There's no back support. When you drag the data into it, data sit in browser. So there's no other backend service that come with Kepler. But with Foursquare Studio, we added services so that there is a backend to store, auto save, and publish and share maps. There's a backend support for collaboration and different analytic modules, and there's also different database connectors. So Studio is I would say, like the hosted version of Kepler, and allowing additional functionality that would require a backend. So some of the feature we add into Studio are, the globe mode and additional charting, some data operations that will require backend and raster support, and advanced visualization that can render 3D models. So there's a list of features that we actually added to Studio that I just enumerated about. With the integration from Kepler, now Studio is more designed for offering spatial visualization and analytic functions for different industries, and we see quick pickup. We're trying to build up use cases for like environmental studies, logistic mobility, and other use cases. So continuously develop Foursquare Studio will ensure us to invest into Kepler. The Studio team at Foursquare is constantly merging PRs back into Kepler. I think we are merging average like 20 PRs per month. It's important to know that whenever we develop a feature into Studio, we if there's no backend support, we keep merging it back to Kepler. So what coming next? I think this is probably a preview for Kepler 4.0. We're merging features like customer color scales. So if you work on visualization, there's infinite features around colors you can add to a visualization tool. We have been working on colors like every now and then. There's always something about colors we could improve. One of those we built into Studio is allowing you to associate colors manually around different different breaks. So this is a feature we'll be merging back into Kepler. Layer column mode is another one. This is something that making visualization more flexible. If you work with different geospatial data, things can come in many shapes like WKT, GeoJSON, individual columns that break down. So one of the support we added to layers is allowing you to draw layers based on however your data is actually shaped. So you can actually draw points based on GeoJSON. You can also draw points based on individual lat long columns. And you can draw trips based on GeoJSON, or you can draw trips based on individual lat long timestamp and ID columns. So added such flexibility, allowing people to have more way of shaping our data. It doesn't always have to follow one single format. This is probably covered earlier. We're going to also adding compass and map scales along with the features, cartography features. So we're currently developing within Studio, and then this is going to be designed as a deck.gl widget, and it will be going back to Kepler as well. So with that being said, some of the we're currently working on Kepler 4.0, same kind of a goal, which we want to keep our tech stack modernized, continuously improving advanced visualization features. Deck.gl 9 is going to add web GPU support, and when Kepler upgraded, there will be a couple of API changes that we need to make. We will also work on vector tile layer support. It's already supported by deck.gl, so enable that in Kepler is something we can do. And as I predict, custom color scales is another thing that we will be including in Kepler 4.0. I think, yeah, that's it. Any questions, comments? All right.